Hi students, today we're starting a new unit on earth science, and so our standard is focused on developing a model to describe the cycling of earth's materials and the flow of energy that drives this process. And today's learning target 1, is about describing the layers of the earth and understanding how heat travels through them through the idea of convection. So we're going to be looking at what the earth is made out of, as well as this new vocabulary word called convection. So let's get started. First question is, we need to look at how Earth is made out of 4 different spheres. So we have the atmosphere, the geosphere, hydrosphere, and biosphere. In the first unit, we really focused on the biosphere, which is the living part of the Earth. We focused on ecosystems, and now we're shifting gears and we're going to be talking about the geosphere, which is basically made out of all the different kinds of rocks and mountains and landforms on Earth. Now, the reason why we divide Earth into these 4 spheres is because all 4 of these spheres interact with each other to kind of shape how Earth is today. Okay, all these 4 spheres create the conditions necessary for life on Earth. So because we are focusing on the geosphere in the new unit, we're going to kind of define them a little bit more in detail. So the geosphere is all of the solid rock of the Earth. It includes all the layers of rocks from the surface of the Earth all the way down to the inner core of the Earth. And if you don't know what the inner core is, we're going to learn about what that is today. And over millions and millions of years, the geosphere has changed. And we're going to be learning about that throughout the unit. So now we're going to get into the layers of the Earth. You may have learned about this in elementary school, but we're going to be learning about it again. So on the outside layer, we have the crust. Okay. Under the crust, we have a thick layer of rock called the mantle. And then underneath that, we have the outer core. And then in the center, we have the inner core. Go ahead and label these 4 words on your diagram, on your notes. And then we're going to talk about them in more detail. So let's talk about the crust first. The crust is the outer layer of the Earth. It includes the layers of the continents as well as the ocean crust on the bottom of the ocean. And it's made out of solid granite and basalt rocks. And we're going to talk about density more in detail, but the density of the ocean crust is actually less than the density of the continental crust. And the crust is actually only about 5 to 25 miles deep. It's the thinnest layer of the Earth. The temperature of the crust is also the lowest compared to all the other layers. It's about 870 degrees Celsius, or if you convert that to Fahrenheit, it's about 1600 degrees Fahrenheit. Still quite hot, and it's only about 0.473% of the Earth's mass. So it's the lightest part of the Earth. Now let's move on to the mantle, the second layer of the Earth. The mantle it's the largest layer under the Earth, under the crust. And it's actually made out of a very slowly moving melted rock that's in between a solid and liquid form. Alright, I decided to include another picture suddenly because this picture is a little bit restricting in terms of seeing the mantle, but this picture you can see a little bit better. The mantle is right under the crust. You can see here the red part right here. And you can see that in the diagram it talks about this flows with the consistency of asphalt. So I want you to imagine asphalt that hasn't dried yet. So that's the concrete, that we see used to make our roads. And think of it as it's kind of in between a solid and liquid form. It's kind of liquidy, but it also has chunks of solid rock, and it's moving very slowly. This layer is about 1,800 miles thick, and it's about 67% of the Earth's mass, so more than half. The temperature can reach up to 4,000 degrees Fahrenheit near the closer you get towards the core. Now let's talk about the outer core. So now we're in the third layer right here, the yellow layer. The outer core is made out of liquid metal. In particular, it's liquid nickel and iron. And it's because it's so hot near the core of the Earth that it's just in a melted form all the time. The temperature can range from 4,000 degrees to 9,000 degrees Fahrenheit. Again, the closer you get towards the center of the Earth, the more hot it is. So 9,000 degrees down here and about 4,000 degrees up here. The thickness is about 1,400 miles thick. And last but not least, let's talk about the inner core. So this is the last layer of the Earth. It's actually the dead center of the Earth right here. Over here in this area, it's actually pure solid metal. And the reason is it's really hot, but because there's so much pressure from all the rocks above it, the atoms there, the metal atoms in here, are actually squeezed together into a solid form and can't move because there's so much pressure. The layer is about 800 miles thick, and the temperature is about 9,000 degrees Fahrenheit. So this is the hottest layer in the center. And then as you move out, it gets less hot. Okay, so you might be wondering, so how do we know what's in the center of the Earth? We really haven't dug all the way through the crust. How do we even know what's in the mantle and the core? Well, the answer is through what we call seismography, which is basically the study of waves through a medium. So they study the waves, earthquake waves, and they study the time it takes for certain waves to travel through different distances in the Earth. And that actually tells scientists more about what this layer is made out of and, you know, what its consistency might be. But we're not 100% sure because we've never dug all the way into the core. But scientists can make predictions based on data that they can use from these studies. Okay, so how hot is it inside the Earth and where does the heat come from? So you guys already know that it's really, really hot in the center of the Earth and 9,000 degrees Fahrenheit. Right now, you can see in this picture, it's in Celsius, but if you convert that to Fahrenheit, it's really hot. So where does this heat come from? Well, it comes from a process called radioactive decay, and this is a picture that actually demonstrates radioactive decay. Basically, what that is radioactive decay is when one atom, which is really unstable by itself, releases a positive charge from inside of its nucleus. I know we really haven't covered atoms yet, but basically this is a positive charge. It releases it, and whenever it spits it out, it releases heat at the same time. And so basically billions and billions of these atoms are inside the core doing this at the same time, and every time it does that, it releases tons of heat, and that's where all the heat comes from. And that heat will travel out towards the outside of the Earth. And um, we're going to talk about this idea of convection now, because the way the heat travels through the different layers is quite different based on the layer. And one of the ways that it can travel is through convection. And this is a really important concept because it ties into the next learning targets for next week. So let's talk about what it is. So you may have noticed that when you boil water, it bubbles to the surface. And basically, if you've ever watched it from the side, or if you've ever watched put some dye into it, you may have noticed that it forms a circular motion. That's actually called convection. And the reason why this occurs is because of density. So here's a picture of density right here. The picture over here shows something that's more dense, and the picture over here shows something that's less dense. So let me type that in there. And basically the idea is that the denser the materials will sink to the bottom, whereas the less dense materials will actually rise to the top. And so what happens is when you heat something, right, you add energy to these atoms or molecules, and when you add energy, they start moving really rapidly and they start moving further away from each other. When that happens, it becomes less dense, so it floats to the top. And then at the top, it's going to be further away from this flame, so it's going to get cooler. When it gets cooler, what the molecules and atoms do is they get closer together, and so they will come back together, but then they become heavier, so then they sink back down. Once they sink back down, they're close to the heat, so the process repeats itself over and over, and that is actually called convection. And why does this have to do with the Earth's layers? Well, convection is a humongous part of how heat travels throughout the Earth's layer. Okay, so let's take a look at this diagram here. You could see that circular motion. And this is actually in the mantle, which is, remember, the thickest part under the crust. We have this circular motion here, and also in the outer core, we have this circular motion. The inner core, of course, is where the radioactive decay is happening, so all the energy is just shooting out towards the outside of the Earth. But this is going to play a big role in how the crust moves. And we're going to go into more detail about this in the next lesson, so I'm not going to talk about it too much. Just know that convection happens inside of the Earth in the mantle and the outer core. All right, now so again, this ties into our next lesson. I'm just going to give you a small preview about what we're going to be learning about soon. But the idea is that this idea of convection under the Earth's surface, the circular motion of the heat, powers a lot of changes on the surface of the Earth where we live. So these pictures here, like volcanoes and earthquakes, all of these happen because of the movement of heat under the Earth. Um, this force also makes new rock types. It moves continents. It could also create new islands. And so we're going to go into more in depth about all of these very soon. But this is it's important because as we learn more about the characteristics of the Earth, scientists can make predictions as to when earthquakes might happen, or the location of new volcanoes and things like that. And so this is why this information is really important. And that's it. Thanks.